stages. This is a graph which shows that how the number of spheres in the Newton's cradle were varied and how the time for the cradle to stop varied. The alignment of spheres. For all the energy and momentum to be transferred from one sphere to the other, the balls should be perfectly aligned. If the spheres are at a certain angle, not all the energy. If the spheres are at a certain angle, not all the energy is transferred. Here we again show a graphical representation of how the angle change from perfect alignment, which is in degrees, 0 degrees, 2 degrees, 4 degrees and 6 degrees, varies varies the time for the cradle to completely stop. Now I would like to address the issue of how the number of spheres initiated might or might not change the rate of decay of Newton's cradle. If 2 balls are initiated rather than 1, the ball swinging out will also be 2. It isn't possible that 2 spheres are swung and only 1 swings out. If momentum and energy are to be conserved, it is not possible that a greater number of balls swings out rather than the number that is initiated. If n is the number of balls initially released and n plus k is the number of balls that swing out, then input momentum is nm, n being the number of balls, nm u1, and the output momentum will be n plus k with m and v square. v2, sorry, my bad. Now from that we could conclude that v1 square is equal to n over n plus k v1 square. However, as n over n plus k is strictly less than 1, so there is a contradiction if v1 is non-zero. Thus, the number of balls swinging will always be equal to the number of balls swinging out from the other side, meaning that the rate of decay will not be affected if the number of balls swinging initially swung are increased.
Okay, opponent, you have 2 minutes to ask that question. Opponent?
So, do you think that we should only release only one ball at one time?
Stated that if we release
no,
two balls.
if I multiply the force you have applied on it, I multiply it with 3 times. What will the effect on the Newton cradle then?
You mean that if you vary the force of the Newton, the force with which it is initiated?
If I increase the distance of a one ball from the other 3 balls, then what will the effect of the force applied on the other 3 balls?
The distance between the balls, if the distance between
these
the balls...
These are 3 balls, this is 1 ball. I am talking about this displacement of the
ball which we will initiate.
Yeah. If I increase that displacement, if I increase that distance 3 times more, then what will the effect on the Newton cradle?
I believe that the rate of decay of Newton cradle will not vary because the conservation of energy and momentum will remain the same and the rate of decay will remain constant.
Okay, so you have discussed in your slides that material of a ball. What if I change the material of the strings?
The strings are attached to the ball.
No, material of the strings can be changed, right?
Yes.
It can be a thread and it can be a elastic.
It is the same parameter if we change the material of the ball or the material of the strings because they are the same. The string and the ball make up one sphere. So if we change the material of the ball or we change the material of the string, it will have the same effect on the rate of decay of Newton's cradle.
All right. Now, opponent, you have 3 minutes to prepare your slides. Where is board marker? Board marker? 2 minutes. 1 minute. You can connect your data. Say on and you can video. So वहाँ
इसको फिर आप अपने लैपटॉप से
Okay, reporter.
You have 4 minutes.
You have 4 minutes.
डिफरेंस को ना अपने ग्रुप से लगा देते हैं
अच्छा, अच्छा।
तो वो बातें हैं
So I'm Naren and I'm here to demonstrate the opposition sides. They presented the problem number 15, which is Newton's cradle. The oscillations of the Newton's cradle will visually decay until the sphere come to rest. Investigate how the rate of decay of a Newton's cradle depends on the relative parameters such as number of phase materials and alignment of spheres.
सर ये नहीं लगेगा.
The good points that have there's a good presentation and mathematical formulas are well used. But the areas of improvements are the working and not shown is not visible that you really performed the experiment. You didn't change the apparatus, you didn't change the strings, you discussed the stainless steels and one more, but did you perform it? It's not in your slide that you actually performed it and you did change the strings graphs are not labeled. In the first graph, you didn't label the what you take in the x-axis and what you're taking on the y-axis. And the time management, some of your parameters are not discussed. The time management observations were not shown. You didn't discuss her observations. Next.
That's it.
Yeah, that's it.
Okay, now you have 12 minutes 21 seconds for the discussion.
So, can you relate Newton's cradle with the third law of motion of Newton?
Every reaction has an equal and opposite reaction. As we see that the ball hits the sphere hits the other sphere with a certain amount of force, and the opposing ball moves in the other direction with the same force if it is in a perfect environment. If the experiment is in an ideal environment, then it will move in the same, the equal and opposite direction.
Okay, in your slide number 12, you have discussed that a ball will strike with other ball with a certain angle.
Yes, the alignment, yes.
Yeah. Did you measure that angle? And can you define deflecting angle also in this regard?
Reflecting angle?
Deflecting angle.
I rightly said that some of the contents were taken from the internet, as I even said in the presentation, and it varied that the two balls were at a certain angle, the deflecting angle in which you are saying. Say I also made a graph of it of 2 degrees, 4 degrees and 6 degrees, which would help us determine if the alignment of balls affects the rate of decay of the cradle.
2 degrees, 3 degrees.
2 degrees for the.
So can you tell me the actual value at which the alignment of the shapes of the ball will not show the Newton cradle working properly?
Will not show. It varies. I'm saying that.
Actually, it was saying that you only copy paste from the internet. You didn't perform yourself, so you didn't measure the angles. You didn't measure the certain parameters.
Like there are critical angles, right? So if if the range of the critical angle is released, then what will happen to the Newton cradle?
If the critical angle is reached, We took 4 different angles. 0 degrees to show how a Newton cradle would work in an ideal environment, which is the spheres are perfectly aligned. Then we did 2 degrees, 4 degrees and 6 degrees. What you are saying that when will it not move? The Newton cradle will not move at all, you're saying. When will it be at an angle? Obviously when the ball will completely miss the other ball. The angle should be such that the ball completely misses the other
actually
ball.
asking about the actual value of critical angle.
What is this related to the critical angle?
I cannot tell that because you haven't performed any experiments regarding it.
I believe you could, if you could please correct me.
Okay, so next question I want to ask that why when you release one ball, the end ball will show some action or reaction. Okay, so why mid balls do not move in that regard?
Because they are packed from both of the sides of the balls. The energy that they receive from one ball is directly transferred to the energy of the next ball, which is this energy conversion starts from NGH. Then there is change in elasticity of the collisions, and then it is directly changed into the kinetic energy of the spheres.
Okay, so what will happen if one ball is small and other is large?
Change in the size of balls.
Yeah.
I believe it will affect the rate of decay of the Newton's cradle. Yes.
Can you elaborate?
The size would change the rate of the decay of Newton's
It
cradle.
was one of the main parameters which you haven't discussed.
I feel that is the parameter I have missed, but I could explain right now. If the balls are of variable size, the mass of the balls will vary. As we can see that this ball will have a greater mass than this ball. And by the equation that I showed, F is equal to ma, we could relate that if the mass increases, the force this will apply will also increase, thus affecting the rate of decay of the cradle.
Okay, so what if I ask you about any practical application of this phenomenon in daily lives?
I think that is totally irrelevant to the problem itself. We are discussing the parameters that will
I
affect the
think
rate
a
of decay.
physician when performs an experiment, he judged that phenomenon to work in a daily life, so that we find benefit of it.
The only benefit we can have from the Newton's cradle is that it is a demonstration of the conservation of energy and the conservation of momentum. That's it. 4 minutes. 8 minutes.
All right. Now, opponent, you have 1 minute to summarize the discussion. Opponent? Opponent?
Okay, so I think that they didn't have much experimental proof to prove that they have performed these experiments by themselves, and they didn't have any. They didn't experience some parameters due to time limitation also. And so I think they should have performed the experiment also, and that's it.
Okay. Reviewer, you have 3 minutes to ask the questions from both opponent and reviewer.
My first question is that what are the 3 laws of Newton? What are the 3 laws that this defines?
Laws of conservation of energy. Newton's third law of motion says that every action will have an equal and opposite reaction. And Newton's second law says F is equal to ma.
Okay. So, can you please tell me why is it called the Newton's cradle? Although it was invented by Simon Pebble in 1938, long after
Actually, feel this is relevant to the problem.
Yes, this is relevant because there is a specific reason that
because it
defines
depends on
this.
Newton's laws. If it depends on Newton's laws, it will be named after Newton. So as it
Okay, so could you please can you tell me the parameters? 3 main parameters of this.
I discussed all the parameters, the alignment of the balls, the alignment of spheres, the number of spheres, and the material of spheres. And as she rightly pointed out that the size of spheres would also vary the rate of decay of the defect gradient.
Okay, can you explain the reason why could you not answer some of our questions?
Which namely are, which question could I not answer? If you could,
There are some.
if you could elaborate. Which question are you specifically asking about?
Can you repeat those questions?
Actually, he